Welcome to the deep dive. It's maybe the biggest question we ask ourselves. Are we alone out there?
It really is. Humans have looked up at the stars for, well, forever, wondering just that.
Exactly. But things feel different now. We've got the James Webb Space Telescope, the JWST, and it's not just looking. It seems like it's making us rethink everything we thought we knew about where life could even exist.
That's precisely what's so exciting. And that's what we're digging into today, some pretty provocative new science, particularly a big review led by Sarah Seeger, the astrobiologist at MIT.
Seeger's work, right.
Yeah, and her team's basically suggesting, well, maybe we've been missing alien life because we've been looking in, let's say, too few, maybe even the wrong kind of places.
So that's the core of it then. Are we actually limiting our chances, our discovery potential, just by searching for planets that look like Earth?
That's the question on the table.
Okay, so in this deep dive, we're going to try and cut through the complexity, give you the main takeaways from this shift in thinking, look at some, frankly, surprising possibilities, and challenge what habitable even means. All without getting too bogged down, hopefully.
Let's do it.
All right. So for the longest time, the main strategy, the traditional approach, was all about finding Earth twins, wasn't it?
Mm-hmm.
Rocky worlds, orbiting stars, pretty similar to our sun. Basically looking for Earth 2.0 out there.
Yeah.
Seemed logical.
It absolutely did. You
Yeah.
start with what you know, right?
Yeah.
But what's really shifting now is that this approach is seen by more and more scientists, Seeger's group included, as, well, overly restrictive.
Overly restricted? How so?
Well, think about it. Finding a true Earth twin seems pretty rare statistically. And meanwhile, we found, what, over 5,000 exoplanets now?
Wow, yeah.
And they're all over the map. You've got boiling lava worlds, massive icy giants. It's an incredible zoo.
Yeah.
So sticking only to that Earth-like model, it might mean we're just completely missing life thriving in environments we wouldn't expect.
So it's like wearing blinders.
Kind of, yeah. It forces us to ask if our very definition of life, or at least a life-supporting environment, has been too, Earth-centric. That's the real paradigm shift here, I think.
Okay, so enter the JWST. How exactly is this telescope a game changer in pushing past those blinders? What's it actually doing?
Well, its power lies in analyzing atmospheres. It can look at the light filtering through the atmosphere of a distant planet and tell us what gases are there. That's huge.
Right, spectroscopy.
Exactly. And this lets us move beyond just hunting for, say, oxygen and ozone, the big biosignatures we look for based on Earth.
Because that's what we breathe or what protects us?
Precisely. Seeger's team, they're pushing for a much broader approach. They call it the all-small molecule approach.
All small molecules, meaning?
Meaning looking for a whole range of simple molecules that life could produce as metabolic byproducts. Think methane, ammonia, maybe even phosphine. Things we see life produce here on Earth, sometimes in weird places, but maybe not the obvious Earth-like signs.
So not just the oxygen signature.
Not just oxygen. Because you have to ask, why should we limit ourselves to Earth-specific chemistry? I mean, look at the life we have right here. It exists in some incredibly extreme conditions.
That's a great point. You mentioned extreme life here. Are there examples on Earth that really back up this idea of life thriving where we wouldn't expect it?
Oh, absolutely. That brings us to extremophiles. These are mostly microbes, tiny organisms that just thrive in places we used to think were completely sterile, totally uninhabitable.
Like where? Give us some examples.
Okay, so think deep-sea hydrothermal vents with incredible pressure and heat, or highly acidic hot springs, or environments soaked in radiation, or super salty water, or places rich in hydrogen, or even carbon monoxide instead of oxygen.
Wow.
These extremophiles, they just find a way. They've adapted metabolisms that are completely alien compared to, say, us or a tree.
Yeah.
They really stretch our definition of livable.
So the thinking is, if life can do that here.
Exactly. Could alien life be doing something similar out there, hiding in plain sight on planets we've maybe dismissed too quickly as uninhabitable? Extremophiles make that seem, well, much more plausible.
This really does stretch the imagination. So if we're moving beyond just Earth-like planets, what are some of these unconventional habitats scientists are now seriously considering?
Okay, this is where it gets really interesting, maybe even a bit sci-fi. One concept gaining traction is the idea of cloud biospheres.
Cloud biospheres, like life in the cloud.
Potentially, yes. We're talking about organisms, maybe microbial, maybe something else, that could live their entire lives floating in the thick atmospheres of planets, not necessarily on a surface at all.
So like on gas giants. Or those super Earths.
Exactly. Planets like Jupiter or Saturn or these super Earths, which are bigger than Earth but smaller than Neptune, often have these really dense dynamic atmospheres. The idea is life could be adapted to just drift within specific layers of clouds, absorbing nutrients, maybe sunlight, never needing to touch solid ground. That's mind-bending.
Okay, so life in clouds. What about challenging the other big assumption, the need for liquid water? Are we thinking about oceans made of other stuff?
That's another huge piece of this revised thinking.
Yeah.
Absolutely. There's the possibility of global ocean planets, worlds, completely covered in liquid, maybe kilometers deep with no exposed land.
Just water everywhere.
Or perhaps not even water. That's the next step. Could life use other liquids as a solvent? Researchers are seriously exploring alternatives like liquid ammonia or methane or even hydrocarbons like the lakes we see on Titan.
Wow, okay, oceans of methane. But wait, don't biological processes like here on Earth need certain dissolved minerals like metal ions? How would life get those on a planet that's just liquid with no rocks to erode?
That's a fantastic question, and it's a real challenge they've addressed. How do you get essential trace elements without contact with a rocky crust? One really intriguing proposed solution is delivery from above. Think constant rain of micrometeorites, space dust, basically. Over geological timescales, this could potentially deliver enough of those necessary trace metals and minerals into the upper layers of these exotic oceans for life to utilize.
Huh. Micrometeorites as a nutrient source.
Huh?
Okay, that's ingenious.
It shows the kind of creative, outside-the-box thinking that's happening now.
So let's try and wrap this up. When you put all this together, looking beyond Earth twins, considering extremophiles, cloud life, alien oceans, what's the big picture takeaway? How does this fundamentally change the search?
I think it transforms the core question. Instead of asking, is this planet like Earth, the question becomes much broader. Could any form of life, as we might conceive it, or even as we can't yet, potentially exist here?
Right, a much bigger question.
It forces us to really redefine habitable. Look at those 5,000 plus exoplanets we know about. That incredible diversity demands a wider perspective, a new lens.
So it's not just about finding more places to look, it's about changing how we look and what we're prepared to find.
Precisely. And the practical next step is building much more comprehensive biosignature databases, catalogs of potential signs of life that cover a whole range of different chemistries and environments, not just Earth-like ones.
To increase the odds of spotting something, even if it's weird?
Exactly. To increase the odds of making that historic discovery. You know, the real takeaway might be that this whole search, it's as much about understanding the limits of our own imagination as it is about finding aliens.
That's a fantastic way to put it. What an incredible time for this field. The potential feels enormous now with JWST online and these new ideas taking hold. Life might not be where we always expected it.
It might show up in a form or place we barely considered before.
Which leaves us, and you listening, with a pretty profound thought, doesn't it? If we do find life, and it doesn't look or act anything like us, or even like anything on Earth, are we actually ready to recognize it?
A challenging question.
Something to ponder. How much do our assumptions shape what we're capable of seeing? What would it mean if the first life we find is truly fundamentally alien? Lots to think about.